Good morning, class. Welcome to our class again. Today, we are going to talk about hyperbola. Now, what is a hyperbola? A hyperbola is the locus of all points in the plane, the absolute difference of whose distances from two fixed points, the first focus and the second focus is a constant. Okay, this is an illustration of a hyperbola, or this is a graph of a hyperbola. So each fixed point is called a focus. Together, they are foci. The center is the midpoint of the segment between the foci. The principal axis is the line that passes through the foci. And a vertex is a point of intersection of the axis with the hyperbola. Note that there are two vertices. Okay, we will go to the theorem. Equations of the hyperbola with center at the origin in standard form. Let C be greater than A and A be greater than 0 and B is equal to the square root of C squared minus A squared. An equation of the hyperbola centered at the origin with case number 1. Foci at the first focus C and 0, and the second focus is negative C and 0, and vertices at V, or the first vertex is A and 0, and the second vertex is negative A and 0. The formula is x squared over A squared minus y squared over B squared equals 1. So that's case number 1. Case number 2 is foci at the first focus is 0 and C, and the second focus is 0 and negative C. And vertices at the first vertex, 0 and A, and the second vertex is 0 and negative A. The formula is y squared over A squared minus x squared over B squared equals 1. So those are the two cases when the equations of the hyperbola with center at the origin in standard form. Now, you have to take note of this. Among A, B, and C, the largest is always C. To distinguish A from B, we check which is involved with the plus term and which is with the minus term. The number A is always together with the plus term. Unlike in the case of an ellipse, the sizes of A and B do not matter. Example, A could be bigger or smaller than or equal to B. Now we will go to example 1. Sketch the hyperbola showing its vertices and foci. So the given equation is x squared over 9 minus y squared over 16 equals 1. So that's the equation of the hyperbola. And we are going to sketch showing its vertices and foci. Our solution is, since the one subtracted is the term involving 16, or ang kauban sa minus is 16, we must have A is equal to 3 and B is equal to 4. Thus, C is equal to the square root of a squared plus b squared equals, okay, the value of a squared there is 9 and the value of b squared there is 16. So from the equation, so the square root of 9 plus 16, which is 25, is 5. And this hyperbola falls under the first case, so that its foci are at positive and negative 5 and 0, and its vertices are at positive and negative 3 and 0. Okay. Why is it that our foci are positive and negative 5 and 0? Because the variable together with the foci is c, so the value of c is 5 man. So we have our foci at positive and negative 5 and 0, and the vertices also, the value there in our formula is the value of a. So a here is 3, which is the square root of 9. So we have our vertices positive and negative 3 and 0. So after locating these points in the plane and noting the transverse and conjugate axes, we form the auxiliary rectangle to obtain the asymptote to which the hyperbola should be approaching. So the sketch of the hyperbola is shown below. So as we know that we have our foci here, we have positive 5 and negative 5. Our vertices, positive 3 and negative 3. And our bases to form the auxiliary rectangle is the value b. So we have positive 4 and negative 4. Okay, we will go to example 2. Find an equation of the hyperbola centered at the origin with foci at positive and negative 7, 0, and vertices positive and negative 5 and 0. So our C here is positive and negative 7, and our A is positive and negative 5. Okay, so this hyperbola falls under the first case of the theorem with C equals 7 and A equals 5. So we therefore also have B. We have the square root of C squared minus A squared. So our C is 7, so 7 squared, we have 49. Our A is 5, so 5 squared is 25. So 49 minus 25 is 24. So our B here is square root of 24. Thus, an equation of the hyperbola is the following: x squared over 25, which is our A squared, and minus y squared over 24, which is our B squared, equals 1. Okay, now we will go to the theorem. Equations of a hyperbola with center at C, H, and K in standard form. So let C is greater than A, and A should be greater than 0, and B is equal to the square root of C squared minus A squared. An equation of the hyperbola centered at CHK with case number 1, foci at F, we have H plus C and K. And the second focus is H minus C and K. And the vertices at first vertex, H plus A and K. And the second vertex is H minus A, and K is x minus h squared over A squared minus y minus k squared over B squared is equal to 1. So that's case number 1. Together with x minus h squared is the A squared, and together with y minus k squared is B squared. So case number 2, we have foci at F, which is the first focus, H. We have K plus C, and the second focus is H, K minus C. And vertices at first vertex, we have H and K plus A. And the second vertex is H and K minus A is y minus k squared over a squared minus x minus h squared over b squared equals 1. So here in case number 2, together with a squared is y minus k. And together with b squared is x minus h. So you have to take note of these two cases so that it will be easy for you to identify what formula you are going to use. Example number 3. Sketch the following hyperbola showing its center, foci, vertices, and asymptotes. The given equation is 16 times x minus 2 squared minus 9 times y plus 4 squared is equal to 576. So what have you noticed with the given equation? That is not in standard form. The standard form should be equal to 1. But here is, we have 16 together with x minus 2 squared and 9 together with y plus 4 squared. And it's not 1, it's 576. So what shall we do first so that we can sketch this following equation? Okay, the first step that we are going to do is transform this equation first into standard form by dividing both sides of the equation by the lone side on the right hand side. So the right side is 576. So we have to divide all terms with 576. So we have 16 times x minus 2 squared minus 9 times y plus 4 squared is equal to 576. So we need to divide all terms with 576. So 16 times x minus 2 squared divided by 576. So we have 16 divided by 16 is 1 and 576 divided by 16 is 36. Minus 9 divided by 9 is 1. So we have y plus 4 squared and 576 divided by 9 is 64. And 576 divided by 576 equals 1. So we have already transformed the equation into standard form. It should be equals to 1. And we will get the center now. The center is then 2 and negative 4. Notice na ang value sa center, it should be the h and the k. So, di ba sa formula, we have x minus h squared and y minus k squared. So, muna siya ang center, the value of the h and the k. So, if we will look at the equation in standard form, so we have x minus 2 squared, and that's the place of x minus h. So, the value of h is 2. And we have here, for the value of k, we have y minus k squared. And there is y plus 4 squared. So, di ba, y plus 4 can be written into subtraction form. It could be y minus negative 4. So, our k is negative 4. So, we have our center now, the h and the k, which is 2 and negative 4. Again, the value of h is 2 and the value of k is negative 4. Since 64 is equal to 8 squared, is the one involved with the minus sign. Okay, let's check. ang involved diha sa minus sign, di ba? Minus y plus 4 squared over 64. So, ang 64 mo involved sa minus sign. So, we must have A equals 6 and B is equal to 8. So, to get the C, we have the square root of A squared plus B squared. So, our A squared is 36. And our B squared is 64. So, you look at the given equation. Diba, ang denominator sa x minus 2 squared is 36. So, mauna siya ang value sa A squared. And look at the denominator also of y plus 4 squared. That is 64. So, mauna siya ang B squared. And why our value of C is 10? Because the square root of 36 plus 64, which is 100, and that is 10. And the principal axis must be y plus 4. Okay, notice the principal axis must be y plus 4 equals 0. Thus, the foci and the vertices all have ordinate y is equal to negative 4. Okay. So, we have y, which is the negative 4. So, pareha ra ang value sa k o ang y. Nga, naa sa center gani. Diba ang k is negative 4. So, same. That's the value of y also, that is negative 4. So, we have the foci at 2 plus and minus 10 and negative 4. And the vertices at 2 plus and minus 6 and negative 4. Meanwhile, the endpoints of the conjugate axis are at 2 and negative 4 plus and minus 8. Okay, because our value of x is 2. The h in the center, which is 2. So, mao po na ang value sa x. So, what case is that? First or second case? Let's go back. Okay, that is case number 1. So, we have here the h is 2 plus and minus the c. And the vertices also is 2, which is the h, plus and minus 6, which is the value of a. And negative 4. Parehara silang value sa y. Negative 4 man ang value sa y. Parehara sa value sa k nga naa sa center. So, the auxiliary rectangle can now be formed to obtain the asymptotes. So, their equations are x minus 2 over 6 equals positive and negative y minus 4 over 8. So, here is the sketch of the parabola. Okay, let's go back here. So, we have the foci 2 plus 10, which is 12. And 2 minus 10, we have negative 8. Ang ato ang vertices is 2 plus 6, we have 8. And 2 minus 6, we have negative 4. And the endpoints of the conjugate axis are 2. We have negative 4 plus 8 is 4, and negative 4 minus 8 is negative 12. So, that's the reason why ingon ani ang ato ang graph for that. Okay, example 4. Find an equation of the hyperbola having center at 2 and 0, a focus at negative 5 and 0, and a vertex at 5 and 0. Okay, just like that of an ellipse, the essential ingredients to the equation of a hyperbola are AB, the center, and the principal axis. So from the center and given focus, we get C is equal to 2 minus negative 5. And 2 minus negative 5 is the same with 2 plus 5, so that is 7. So we have C, 7. And from the center and given vertex, we get A is equal to 5 minus 2 is equal to 3. So we have our C, 7, and our A is 3. Thus, to get the B is equal to the square root of C squared minus A squared. So we have our C is 7, so 7 squared is 49, and our A is 3, so 3 squared is 9, so 49 minus 9 is 40. So our B is the square root of 40. Finally, the principal axis passes through all the given 3 points. Since there are 3 points satisfy the linear equation y is equal to 0, this must be the equation of the principal axis. So, an equation for the hyperbola is therefore the following. X minus 2 squared over 9. 9 is the A squared minus Y squared since our K is 0. So, Y minus 0 squared is the same with Y squared. And our B squared is 40. Equals 1. So that's the equation of the hyperbola. Okay. So we have number 2, having the points negative 5 and negative 3, and 4 and negative 3 as the endpoints of its conjugate axis, and whose transverse axis is as long as the conjugate axis. So how we will solve this. So for the solution, we have the center is just the midpoint of the conjugate axis. So we will get the midpoint. We have x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So negative 5 plus 4 is negative 1 over 2. So our x is negative 1/2, and negative 3 plus negative 3 is negative 6 divided by 2 is negative 3. So our center is negative 1/2 and negative 3. Meanwhile, since the length of the conjugate axis is 2 times the b, we therefore have b is equal to 4 minus negative 5 divided by 2. And 4 minus negative 5 is the same with 4 plus 5. So 4 plus 5 is 9 over 2. Here, we have used the observation that the conjugate axis is along the horizontal line, y is equal to negative 3, because that's the value of the k at the given center. Diba, ang ato ang center is negative 1/2, which is the h. And parihara na siya sa x. And our k is negative 3, parihara po na siya sa y. So we have y is equal to negative 3. Now, since the principal axis is perpendicular to the conjugate axis at the center, it must then be the vertical line x is equal to negative 1/2, which is the h of the center. So, parihara ng x o h. Finally, the last condition simply says that a is equal to b. Actually, 2a is equal to 2b. We therefore have the following as an equation for the hyperbola. We have y plus 3 squared over 81 over 4 and minus x plus 1/2 squared over 81 over 4 is equal to 1. Why? Nganong ka na ang equation? Okay. The h is negative 1/2 and the k is negative 3. And that is case number 2. So we have y minus negative 3 is the same with y plus 3 squared over 81 over 4 because our b is pareharag value ang a squared o ang b squared because same raman dito sa given problem. It becomes 81 over 4 because our b is 9 over 2. So we square 9 over 2. So 9 times 9 is 81 and 2 times 2 is 4. Since equal naman ang a of b, so parihara sila o denominator, that is 81 over 4. And here we have minus x plus 1 half because our h there is negative 1 half. So x minus negative 1 half is the same with x plus 1 half squared. So our equation for the hyperbola, we have y plus 3 squared over 81 over 4 minus x plus 1 half squared over 81 over 4 equals 1. So we will go to the historical gem, the branches of the hyperbola. There was a time when only one branch of the hyperbola was considered, the entire hyperbola. The first to study the hyperbola with its 2 branches was Apollonius of Perga, as he was the one to first derived conic sections from a double-naped cone. Menaechmus, who is regarded as the discoverer of the conic sections, only used a single-naped cone. So for our integration of faith and learning, like hyperbolas, we may have curves in our lives. Even if we encounter lots of problems and trials in our way, we must always remember that there is God who keeps watch over to remind us with the straight line, which is the path of righteousness. Despite of the x and y, or the positive and negative sides that we have, we must put in our minds always that God is always there for us. That's all. I hope you learn about hyperbola this morning.